All right, so here's our homework help video for today's lesson, since I kind of shorted you out on the lesson today. So let's begin. So we talked about how to solve these problems by multiplying the denominators. So I'm going to start by multiplying everything by 2x squared. And in this case, these go away. In this case, the 2's cancel. And the x will take away one of the x's, so I'll be left with just x instead of x squared there. And on this one, the x squareds go away. So what I'm left with then is a 1 minus 1x equals 1 times 2, which is going to be just 2. So this is what we're left with, basically. Minus the 1 on both sides. Divide both sides by a -1. And we got x equals -1. Want to make sure it doesn't make any of the bottoms equal 0. If you plugged in -1 to those, you would not get 0, so we're good to go. So that is my answer, -1. All right, next one. Just more of the same. Here we go. So I want to get rid of the 2p squared there, so I'm going to multiply everything by 2p squared. I guess the little difference here is the fact that we have binomials, so you'll notice I'm putting those in parentheses. 2p squared cancels out. The p squared cancels out on both of those ones. So on the one here on the left, I'm left with this minus. Here I have 1 times 2 left, which is 2. And here I've got 5p minus 3, and then I still have a 2 on the outside there. I'm going to put it in the front. So we'll distribute, combine those together as well, and we'll start solving. So p equals 1/3, and once again, that's not going to make any of these bottoms equal 0, so that's a good answer to keep. All right, next one. Okay, so now we start getting into some of the more hairy ones that you guys might have been having some issues with in class today. Notice that in this case, we have binomials in the bottom, and they can be factored. So when you have binomials that can be factored, or even trinomials that can be factored in the denominator, go ahead and do that. So p squared minus 16 is a difference of squares. If you factor that, you're going to get p minus 4 and p plus 4. This one doesn't factor, it's just the same. This one is the same one as the first one we did. It's p minus 4 and p plus 4. Okay, so now we're going to multiply everything by the denominators. So p minus 4, p plus 4, p minus 4, p plus 4, p minus 4, p plus 4. And then we'll cross off. Oop, on this one, only the p plus 4 cancels out. The p minus 4 is going to stay. And then the last one here, those go away. So let's see what we have left. The first one now is just 4. The next one is a p minus 4 to the 4. I like to put the 4 in the front and the p minus 4 afterwards. And then here we're left with just p minus 1. And then we'll go ahead and solve from there. and I get 11/3. Now, what's going to make our bottom equal 0 on this one? It's not, first of all, I already know this answer is a good answer, but what isn't a good answer? Like, what would we not be allowed to have for p? Well, here we have p minus 4, right? What would you plug in for p so that that becomes 0? 4, right? So p cannot be equal to 4, and here p cannot be equal to a negative 4. So long as our answer is not one of those two things, we're good. Our answer is not one of those things, so we're good. That's our final result there. All right, let's move on to another one. More of the same stuff here. I would encourage you guys to try this one on your own if you haven't already. But we're going to start by factoring the bottoms, just like on the last problem. So here, the way you factor this, though, is that's a difference of square. That's not a difference of squares, sorry. That's a GCF problem. So I'm going to take out an x. Take out an x, this is what you have. The last one doesn't factor. And now I'm going to multiply everything by that denominator. Okay, and cancel. On this one, the x takes the x. Let's see what we have left now. We have just a 1 left there. Here we have x plus 6 in parentheses. And then at the end we have 1 times x plus 1, which we're going to distribute to just get x plus 1. Over here we're going to distribute the negative to get negative x minus 6. And then we're going to combine our 1 and 6 there to get 7. Add the x over to get 2x. And just continue solving. X equals 3. Now, in this particular problem, I know 3 is a good answer because this can't equal 0. And for this one, x can't equal negative 1. So long as our answers are not negative 1 or 0, we're good. And that answer is neither one. So that's an acceptable and good answer to keep. All right, let's go ahead and move on to yet another question. All right. Now this is the rest of these are probably where it's going to start getting into the ones where you would probably want some help. But once again, I would say, try them on your own, and then if you're still stuck, then come hit up and watch the lesson. So, well, first of all, notice this is just n minus 1. I guess we could leave it like that. It's fine. I want to get rid of the n minus 4, though, right? So that's what I really want to do. So I'm going to multiply everything by n minus 4. Okay. So I multiplied each of the pieces by n minus 4. These go away. These go away. Nothing goes away here. Okay, so I've got 6 is equal to just the top now, because the bottom's gone, minus this. So here's one difference. And we talked about that in class today. You guys hopefully recognize that that's a box problem, right? So we need to do the box multiplication to figure out that answer. Okay? Now I'm going to put it in parentheses, though, because we are subtracting it. So I want to remember to distribute the negative when I'm all done. But if we did the box multiplication or the FOIL method or whatever method you choose to use, you would get n squared minus 5n plus 4. Okay? Then we're going to distribute the negative. Then we're going to combine our like terms. The n squared and the n squared cancel. That's good because now it's not a quadratic anymore, and it'll be a basic, simple problem to solve. Negative 8n goes with 5n to make negative 3n, and then 15 goes with negative 4 to make 11. So now we just finish up the problem there. That's negative 5 equals negative 3n. Dividing both sides by negative 3, we get 5/3, which once again, that's a good answer because the only thing that n cannot equal is 4. Now some of you guys might be thinking, wait a minute, shouldn't we say that n can't be 1? The answer is no, because this is not a denominator, right? That rule about what n is not allowed to equal only applies to the denominators. So the only thing n is not allowed to be is 4. Since our answer is 5/3, that's a good answer, and we're going to keep it. All right, so the new twist on that one was the box method there. Let's see what the next one brings us. So once again, we're going to start by factoring the denominator. It's a GCF problem. I'm going to take out a k. So if you take a k out of there, this is what you would get. And now we're going to multiply everything by the denominator, k plus 4. Cancel stuff out. Now over here nothing cancels. Here those all cancel out. On this one just the k plus 4 cancels out. So what am I left with then? I've got a 1, I've got a k, and then I've got a k plus 4. Plus 6 is all that's left from that middle one. And now on the end I have 2 k's. And 2 k's being multiplied together is just going to be k squared. So let's go ahead and distribute and multiply. So I get k squared plus 4k plus 6 equals k squared. And then we're going to put the k squareds together. And another lucky situation, the squares go away. So I don't have a quadratic. That's nice. And we just solve what's left. Reducing that fraction, you get negative 3/2, which is totally cool. The only thing that k cannot be is k cannot equal 0, because that would make the bottom equal 0, and k cannot equal a negative 4. So since our answer is neither one of those, our answer is a good one. And you're probably thinking, okay, this is stupid. Why do we keep checking for that? And I told you it's because very rarely does it happen, but it does happen where the answer you get is one of the things you're not allowed to have. So we always want to be checking for it. Okay. Well, let's go ahead and do another one here. In this case, I don't need to factor the bottoms because you can't factor the bottoms. So, but I am going to put my binomials into parentheses here, and my trinomials too. Okay, so we want to multiply everything by the denominator of k plus 6. Sorry, x plus 6. And in this case, these go away. These go away. So we're left here with 1. Here we have k plus 6 being multiplied. I think I keep saying k, it's x. We have x plus 6 being multiplied with x plus 1. Plus that guy. We need to box that out. That would give us x squared plus 7x plus 6. On this one, I'm not going to distribute a negative because we're adding. So X squared plus x squared doesn't cancel this time. It actually gives me 2x squared. That means I'm left with a quadratic. So this is where things will get interesting. 7x goes with 4x to make 3x. 6 and negative 5 makes 1. Okay. Now when you have a quadratic, the strategy is to move everything over to one side of the equal sign. That's the first thing you'll do, is move everything over to one side. The next thing you're going to do is you're going to factor the quadratic. So as I'm looking at this thing, I see there's a GCF. The GCF is x. I can take out an x. After you take out the GCF, you do the zero product property. You set each piece equal to 0 and solve. So here's one of my answers, x equals 0. And here's my other one. So in this case, I get 2 answers. You know,
You're teaching a lesson.
yeah. Hey, how's it going? Hey, Pearl. Both of those are good answers. The only thing that x is not allowed to be is negative 6. So since neither one of those are that, then these are good answers. The answers are 0 and negative 3/2. Yeah. Oh, and it looks like that was our last one. Huh. I'm a little disappointed in that. Hold on a second. All right, last problem that we'll do here. We'll multiply all of our terms by p plus 3 to get rid of the denominator. So p plus 3, p plus 3, and I'll squish a p plus 3 in over here. Cancels and cancels, cancels and cancels. And we have p minus 1 and p plus 1. All right, so this is going to be p squared plus 3p. Here, the 2 p's add to make 2p. Negative 1 and positive 1 cancel. Minus your 2p on both sides. And then we factor. And once again, it's another GCF, but don't be too comfortable. Sometimes you could end up with like a box method or a difference of squares or something like that. But in this case, it's just another GCF. And we set each piece equal to 0. So p equals 0 and p plus 1 equals 0. Solving the last one, we get that. Oops. So here's our 2 answers. The only thing that p is not allowed to equal is 3, so we're good to go. All right, and that does it. So hopefully that was helpful to you guys. See you later.